Thanks very much, Rakesh. And hello, everyone. So my question is, do we really need to clean up space? Rakesh has given us an intro, but what I'd like to explain to you today is why we need to do this and what that means for us. So my name's Nick. I'm from a company called Astroscale. I'm really pleased to be here today. So space is big. This is Bruce McCandless back in 1984. I can't believe that's 40 years ago. He was floating away from about 100 meters from the International Space Station, totally without tethers or anything. Incredible. So if space is so big, why do we need to worry about cleaning up any mess that we've put in orbit? Space development started in 1957 with the launch of Sputnik, the Russian satellite. Then we saw the space race. We saw moon landings with Apollo and Neil Armstrong in 1969. And then slowly we started to see commercial development of space. Through the 1980s, we saw communication systems, satellite TV, Sky here in the UK. And we saw communications to ships and planes all around the world. Then, in 1990, a system built by the US Department of Defense called GPS became available to the general public. And we saw more and more development of space. So it's really been a governmental, for the first 30, 40 years, it was a governmentally led, space agency-led development of space. Over the last 20, 25 years, that's changed massively. We've moved to a commercially led, commercially oriented space sector with companies like SpaceX, Blue Origin, Planet, and many others. And I think we're going to see that continued growth going into the future. And that's where the real innovation is now. It's in the commercial sector. So, what about our dependence on technology? We live in a society exquisitely dependent on science and technology in which hardly anyone knows anything about science and technology. An excellent quote from Carl Sagan, the great American cosmologist and visionary. And I think, as already said, we've seen a lot more dependence on space. GPS, as I've already mentioned, not sure if you knew, GPS is a very complex system. It has 24 satellites in a medium Earth orbit. It has atomic clocks on board those satellites, and it uses Einstein's theory of relativity. There's only two systems globally that are required to do that operationally, atom smashers and GPS. And we benefit so much from all of those applications that GPS enables. That's just one example. We're seeing global broadband communications become much more prevalent. If you look up on a dark night, you'll see Starlink satellites whizzing overhead. There's now 6,000 of them in orbit. And Elon Musk has authority to launch another 8,000, and he'll probably get more. There's others coming. There's a company called OneWeb that's based here in London, and more to come as well from companies like Kuiper, funded by Amazon. So we're going to see more and more development of space, and we're going to become more dependent. Earth observation, another really important area. We've heard quite a lot about that today. We use Earth observation for weather forecasting, for hurricane forecasting. We use it for climate monitoring. You cannot monitor half of the variables that the UN wants to monitor for climate unless you use space. So as you can understand, we are becoming very dependent on space, and we will get more and more in the era of driverless cars and urban air mobility, again, dependent on communications from space and navigation from space. So back down here on Earth, we've started to clean up the mess we've left in our atmosphere and in our oceans. 12 million tons of plastics are put in the oceans every year. But the UN is starting to put in place globally agreed treaties to manage that plastics pollution. So we're starting to make headway in these sorts of areas. However, in space, we've had a throwaway culture since 1957. we've left 3-ton rocket bodies and bigger objects in space just to orbit in multiple different orbits, crisscrossing as well. And that creates significant orbital problems that we're going to see more and more of. So I think there are, the opportunity is there to develop systems to actually manage this problem that we have. Let me talk about the orbits that we use just briefly as well. Humankind has used 2 main orbits so far. On the left-hand side, you can see low Earth orbit. That's sort of from 200 kilometers orbit height, about from here to Sheffield, to 2,000 kilometers orbit height, which is sort of here to, say, Athens. And that is becoming very congested and contested as well. It's becoming actually a domain, potentially, hopefully not, of warfare, but we'll see where that goes. On the right-hand side, geostationary Earth orbit. That's about 3 Earth diameters out from the Earth's surface, 36,000 kilometers. And that should actually be called the Clarke orbit, after Arthur C. Clarke, because he in 1945 identified and that this was an orbit that we could all use. It's basically important for us because the spacecraft in those orbits orbit exactly the same period as the Earth turns. So they appear stationary to the user on the Earth's surface. That's why your Sky TV dish on your house, if you had one, was stationary. It didn't need to move. If you look closely as well on that right-hand image, you'll see in medium Earth orbit some planes, which is about 22,000 kilometers orbit height. That's GPS, and that's that system that we depend on, as well as many others, from space. So what are we doing to address this space debris problem? Well, the UN and many other international bodies, and also a number of governments, are starting to put in place policies. We're starting to see some regulations coming, which are requiring satellite operators to clean up after they end their lives of their satellites and reduce that orbital pollution that we have. So we are starting to see things come into place, but there's a lot more to do. And that's one of the things that Astroscale is working on. So space debris is a global problem. There's no laws in orbit. There's the Outer Space Treaty, which was established in 1967 by the UN. However, there's no borders established in space, like on Earth or in air zones as well, for example, in aircraft. So those treaties that were set up many years ago are not really fit for purpose anymore because of that commercial exploitation that I've explained. On the right-hand side of this diagram, you can see a NASA graph with the number of objects in orbit that are increasing. You see the sort of exponential increase over the last few years that's continuing now. That's the growth of low Earth orbit constellations I mentioned, like Starlink. You can also see a couple of events in that graph. Unfortunately, we had some anti-satellite tests, one in 2007 and one only in 2021, as well as a collision between an American and a Russian satellite in 2012, which caused an uplift in debris. And those collisions, unfortunately, are going to continue. So we do have, as said on the left there, 130 million pieces of space debris. And the risk of in-orbit collisions, like I've mentioned, are increasing. And that's the thing we need to manage. SpaceX, Starlink, the system, had to maneuver 6 times every hour last year. So they had to move their spacecraft constantly. And that's really something that's only going to increase, that we have to really work to manage. So what are we doing to address this problem? I've mentioned some of the policies that some international organizations are working on. And we are looking at developing technology which will help manage this issue going forward. Astroscale is a company that was established in 2013. We're the first private company with a mission to clean up space, to make it sustainable for future generations. Here are some of the missions that we've built or are building at the moment. Bottom right, ELSA-D, that was launched in 2021, that went up and demonstrated how we can capture, using a magnetic capture system, a different object in orbit. That's very successful. That's now sustainably deorbiting itself. The top left spacecraft is one called Address-J. That's active debris removal by Astroscale Japan. That was built in Japan. A lot of the operations was done here in Harwell, which is near Oxford. That's where we're based here. And all those other missions that you can see on there, and 2 or 3 others, we are building now across our different entities. We are headquartered in Japan. We have an office here in the UK, as I've said. We have 2 offices in the US and 1 in France. We opened last year. So we are growing. We have over 550 people now building this technology. We see a big commercial market as well as an institutional market in this new business area. The top left spacecraft, Address-J, as Rakesh mentioned at the start, is the spacecraft that's in orbit now. It was launched in February this year, and it's approached a large rocket body that was launched in 2009. Ironically, to launch an Earth observation climate monitoring satellite, but it's left a lot of debris in orbit. This is the picture we took a couple of weeks ago from about 200 meters away from the debris object, and we're approaching it closer as well. It's hard to do this. It's hard to get close. We have a technique called rendezvous proximity operations, which is how you get closely, gradually towards an object in a safe, robust, and secure way. The last thing we want to do is create more space debris, obviously. And that RPO, or rendezvous proximity operations, is a technique that's critical for so many other applications in space. It's critical for building objects in space, manufacturing in space. It's critical for refueling objects in space, which is a new service that's coming. So this image is the first image taken ever of a debris object in space. And we're going to get closer, as I said. So coming to my bold prediction, we don't want to end up in a situation like this, looking back at Earth from a future commercial space station with all those debris objects. I predict there's going to be a new, fast-growing off-planet economy over the next 10 years. So by 2035, that off-planet economy will fuel a 1 trillion space industry, which is predicted by many market analysts at the moment. So we need to clean up space to enable this economy to happen and to enable us to move out to colonize the moon, Mars, and onwards into the solar system. And I think that's what we need to do. So answer to the question I've posed is yes, the need is clear, and the time to act is now. Thank you very much.